Okay, we're going to work today on some operations with radical expressions. So now that we've done some work with what radicals are, we're going to do some adding and multiplying. Okay, so adding and subtracting radical expressions. We're going to treat radicals like variables when we're adding and subtracting. In other words, 2x plus 7x is 9x. In the same way, 2 radical 11s plus 7 more radical 11s are 9 radical 11 pieces. So you notice that the variable doesn't change, the radical doesn't change, we're just adding like terms by adding the coefficients. The same thing happens with subtraction. If I have 14y minus 4y, got 14 of these things minus 4 of them, I end up with 10. Same thing, this time the radical is radical 3. They have to match, they have to be like terms, but 14 minus 4 is 10. And we haven't changed what we are adding, just how many of them we have. So, like terms. So let's try one. Oh, come on. All right, so these are like terms. The radicals are the same, radical 13 and radical 13. So all I have to do is add the 2 plus the 14, and we get 16 root 13. Okay, try this one on your own, and then come on back. Okay, 2 plus 6 is 8. Minus 13 is negative 5. They were all root 3 terms, so I can add them together and then subtract 13. So pretty easy when we have like radicals. Now, what happens when we have unlike radicals? Well, just like with variables, if I have 2x plus 3x plus y, I can add the 2x and the 3x together, but I cannot add the y. So something similar will happen when we have unlike radicals. All right, so here's an expression. Now, at the moment, it doesn't look like any of these radicals are the same. However, several of these radicals can be simplified. So let's look at this. Square root of 20 is root 4 times root 5. Square root of 45 is root 9 times root 5. And the square root of 180 is, it's 36 times 5, but let's break it down a little bit. I would first look at root 9 times 20. 9 times 20 is 180. And square root of 15 I cannot simplify. So 2 times 2 root 5, I'm just simplifying each term as I go along, minus 3 times 3 root 5, plus 3, root 20, I already know from back here that root 20 is 2 root 5. And as we said before, root 15 can't be simplified. So I have 4 root 5 minus 6 root 5 plus 6 root 5 minus root 15. Well, negative 6 plus 6 is 0. So my final answer is 4 root 5 minus root 15. So the first thing you have to do is simplify all radicals. Then you can see whether or not you can add or subtract. Let's try one more of these. I guess that's the only one I did. Go back. What happened? All right, yep, that was it. All right, multiplying radicals. So to multiply radicals, I'm going to multiply the integer portions together and then multiply the radical portions together. Again, think of variables. 2x times 3x. 2 times 3 is 6. X times x is x squared. So let's see how this works. 2 root 3 times 5 root 6. 2 times 5 is 10. And then I've got to multiply root 3 times root 6. So that's 10 times the square root of 18 using our product rule. And then I've got to be careful because this can be simplified now. Root 9 times root 2. That's 10 times 3 root 2. And my final answer is 30 root 2. So as with everything else, once I've done my operation, I have to look to see if I can simplify. All right, let's try another one. And now we are going to look at multiplying radical expressions. So now I've got a binomial times a binomial. I am going to FOIL. Anytime I have a binomial times a binomial, I'm going to FOIL. First times first. 2 root 5 times root 14. Outside. 2 times negative 2 is negative 4 root 5 times root 35. I went ahead and multiplied my coefficients and then wrote out what I was going to do. Inside, root 2 times root 14, and last coefficient is negative 2, root 2 times root 35. So, 2 times root 70 minus 4 times root 175. 5 times 35 is 175. Plus 2 times 14 is the square root of 28. Minus 2 times the square root of 70. 2 times 35. So I have two like terms here, and it's kind of nice because they cancel out. 2 root 70 minus 2 root 70, that's 0. Now I've got to simplify these. This is the square root of 25 times 7, and this is the square root of 4 times the square root of 7. So negative 4 times 5 root 7 plus 2 root 7, that's going to be negative 20 root 7 plus 2 root 7. Final answer is negative 18 root 7. I have one more to do of these, so try this on your own, FOIL this, and then come on back. Okay, first times first. 9 times the square root of 49. Root 7 times root 7 is root 49. 3 times 3 is 9. Outside, plus 12 root 7. Inside, minus 12 root 7. And last is negative 16. Plus 12 minus 12 is 0. Did you notice before you started that this is a conjugate binomial pair? Anytime we have the same beginning and end, 3 root 7 and 4, 1 plus 1 more 1 minus, that middle will cancel. And then look what happens here. 9 times 7. Since I was multiplying a radical times itself, I always will get an integer, minus 16. So that's 63 minus 16, which is 47. Anytime I multiply a conjugate binomial, I will eliminate all of my radicals. A times square root of A times square root of A is A. The outside and inside cancel, minus B. And that will always be my answer. So that once again, we have this idea of a conjugate binomial that does some pretty special stuff for us. All right.